Okay, today's lesson is going to be section 11-3, and today's objective is all students will be able to solve problems involving the circumference and area of a circle. So as I go through and do this video lesson for the first time, what I'm going to do is every once in a while I'm going to pause it on my end to get some stuff set up, and then I encourage you on your end, if you need to pause the video to finish writing something down, or if I ask you to try an example and work through the example on your own, you can press pause, and then when you're done working it out, resume and you can see how you do on that example. Okay, so the first thing we need to do is define mathematically what a circle is. So here's the mathematical definition of a circle. A circle is the set of all points equidistant from a given point. A circle is the set of all points equidistant from a given point. So let me give you an example. Let's say that we have this point right here. And let's say that I extend a distance here. If I draw the set of points that are all the same distance from that point, that is what's going to be our circle. So let me go ahead and draw that circle here. Okay, not bad. I used the computer to help cheat a little bit where it automatically, I made a rough sketch of the circle and it cleaned it up for me. All right. So let's give some definitions based upon these pieces of our circle. So the circle itself is the one that's in blue there. That is our circle. This point that is where we started our measurements from, that is the center of our circle. If I draw that distance, this distance here that was equidistant from the center to the circle itself, we call that distance, or that segment, we call that the radius of the circle. And it doesn't matter where that radius is on the circle, the distance is always going to be the same. So for example, this radius has to have the same length as that radius. If I draw two radii, radii is the plural of radius. If I draw two radii such that they go from one end of one part of the circle through the center all the way to the other end, like this one right there, that is what we call the diameter of the circle. So the circle itself is equidistant from the center. That distance is called the radius of the circle. And the diameter consists of these two radii, the two radiuses, the two radii, from one end of the circle through the center to the other end. So here's one radius, here's the other radius. All radii of a circle are congruent, which makes sense. That they represent that equal distance from the center to the circle. All of these radii need to have the same length. Therefore, they are all congruent. And since this diameter consists of two radii, we can say that the length of that diameter is equal to 2 times the length of the radius. That is, the length of the diameter is double the length of the radius. If this radius was 4 centimeters, this whole diameter would be 8 centimeters. In shorthand notation, d is equal to 2r. Diameter is equal to 2 times the radius. We also can look at it the other way around and say that the radius, the length of that radius, is 1/2 the length of that diameter. Again, remember, we know that the diameter consists of 2 radii. So let's say that we know that this diameter is 10 inches. That means one radius is going to be half of that, 5 inches. So we can just write down r is equal to 1/2 d. All right, now that we have those pieces in play, let's talk about the circumference of a circle. The circumference of a circle is the distance around the circle. So if I start at one point and I go all the way around the circle back to where I started, the length of that distance that I traveled is called the circumference of the circle. One thing that I'm not going to see, and I'll have to get used to if I'm going to be doing this, is recognizing that with my picture here in the bottom right corner, sometimes it might overlap what I'm writing and I might not see it right away since I'm looking at my notes on another screen. I'll try to get better at recognizing that and taking that into account. So sorry if that gets in the way of anything. All right. Now, if we take any circle and we find its circumference, and we divide that circumference by the diameter. So I'm finding the ratio of the circumference of the circle to the diameter of the circle. For any circle, what's always going to be true is that ratio is always going to be equal to what we know as pi. Pi is approximately 3.14159, and it keeps on going on and on and on. It doesn't come to a stop, it doesn't terminate, and it doesn't repeat any patterns, so it's non-repeating. You might remember that this is what we call an irrational number. Any number that doesn't repeat and doesn't come to a stop is what we call an irrational number. Now, we can take this formula, if I write it in shorthand notation here, C over D is equal to pi. The circumference divided by the diameter is equal to pi. And if I want to solve that equation for C, I want to get the C by itself, I'm going to undo the division. We undo division using multiplication, so I'm going to multiply both sides by pi. So we get that the circumference is equal to pi times diameter. That's one of our important formulas. Circumference is equal to pi times diameter. Well, if I take that formula and we know that the diameter is equal to 2r, I can replace d with 2r. I can make that substitution. So what we can say is that, therefore, the circumference is equal to pi times 2r. That's my substitution. And since I'm multiplying three things together, that's the same thing as, well, mixing the order around. The order of multiplication doesn't matter. It's commutative. We say circumference equals 2 pi r. You could use either formula to find the circumference depending on the information that's given in the problem. So that's how we work with the circumference of a circle. Now, the area of a circle that formula is given by A equals pi r squared. A equals pi r squared. The area of the circle is equal to pi times the square of the radius. Now, to get that formula, getting like a direct algebraic derivation is a little bit beyond the scope of this course. But if you're interested in maybe like a pictorial example of why that formula works the way it does, look at this setup right here. You don't have to copy this down, but take a look at this. If I take this circle and I divide it into 16 sectors, blue, red, and so on and so forth, there's 16 of those different sectors. And what I do is if I take them out of that circle and rearrange them into, well, it kind of looks like a parallelogram. I mean, we get some curves here, but we're going to approximate it as this parallelogram. The area of this parallelogram is going to be the same as the area of this circle. Well, if I arrange the sectors of the circle into this parallelogram, the distance from the point of each of those sectors all the way down to the bottom here, that's going to be the radius of the circle. That's the same as what we can see in the picture. Same idea here, from this point all the way here. So that's why this distance, they're calling the height of the parallelogram r. We know that the circumference is 2 pi r. That's the distance all the way around. Well, if I just look at the red pieces here, okay, those make up about half the circumference. If I take a look just like those arcs along the red sectors. So if I take 2 pi r, and I divide that by 2, because I only want, like, say, the reds, and those 2's cancel out, I'm left with pi r, which is what the length of that side of the rectangle is. So to get the area of the circle, what we're doing is taking pi r times r, and since r times r is r squared, that's how we get to the formula of the area of that circle is pi r squared. So now that we know our formulas, let's go and do some examples. All right, here's our page of examples. We're not going to do all of them. We're going to kind of skip some. Maybe we'll just do the odds. So let's look at some different types of problems. Problem number 1. Find the circumference of each circle. And it says use your calculator's value of pi. If you're stuck on how to use the calculator to get that, go ahead and raise your hand and we can help you out figuring out how to use that on your calculator. But I'm going to proceed as if you're all set with that, but just raise your hand if you get stuck. So we want to find the circumference of the circle. For problem number 1, we're given the diameter of the circle. So we have two formulas for circumference. One if we know the diameter, and one if we know the radius. So we're going to say that, write down our formula. Since we know the diameter, we're going to use circumference equals pi times diameter. Then I'm going to replace the diameter with what's given. So circumference equals pi times 14.8. Then I'll jump to my calculator. And when I type that in, I'm going to get a whole bunch of different decimal places here. 46.49557127. Don't use 3.14. Let me write that down here. Do not use pi equals 3.14. I want you to use your calculator. Use your calculator's button to get pi. When you do that and you get this value, what do we have to round to? Well, the directions say round your answer to the nearest tenth. The nearest tenth is 1 decimal place. So here's one decimal place. Since there's a 9 that comes after it, I round it up. If this next digit is like 5, 6, 7, 8, or 9, we round up. If it's a 0, 1, 2, 3, or 4, we keep it the same. So my circumference, let's do that in red. The circumference is equal to 46.5 meters. For any of these problems, you can always, before I start working it out, if you think you know how to do it, try it on your own, then just press pause, try it on your own, then compare it to mine. Let's take a look at number 3. To get the radius, well, we're given the radius. The radius is 7 feet. So we'll use our other formula, circumference equals 2 pi r. The radius is 7 feet, so we're going to do 2 pi times 7. So in my calculator, I'm going to type in 2 times pi, using the pi button, times 7. When you type that in, you get 43.98229715, and it keeps on going. To round to the nearest tenth, we look at this 9 after it comes an 8. I need to round this 9 up. So when I round it up, 9 actually rounds to be 10, which means this I have to add 1 to, and that's going to be 0. So that's really the 10 that I'm going to end up getting. I'm going to round that off to be 44.0 meters. The units of circumference, since circumference is a distance, we're using our linear units. So meters, for example, or inches, or centimeters. We'll use the square units when we get to area. All right, problem number 5. To find the diameter of the circle, we're going to have to work backwards. We know the circumference, and we're trying to find the diameter. So what's our relationship between circumference and diameter? Our formula, circumference equals pi times diameter. The circumference is 18.8, so I'm replacing C with 18.8. The circumference is 18.8. That's what I know. So that's why I'm plugging it in for C. Equals pi times D. We don't know what D is. That's what they're asking us to find. So I'm going to leave that as D. Now, to get the D by itself, I'm going to divide both sides by pi. So in my calculator, I'm going to type in 18.8 divided by the pi button. Since these D's cancel out, I'm just left with D on that side. I'll just switch the order around the equal sign and say D is equal to, if I type in 18.8 divided by pi, I get 5.984. Since that 8 comes after that 9 to 1 decimal place, we round that 9 up to 10, which means this becomes 6.0 kilometers. All right, number 7, a little bit different. This time they're asking us to find the radius, and we know the circumference is 18.8. There are a few different ways in which you might approach this. I'll show you both ways. One way is, some people always just like remembering that formula. If we know something about radius and circumference, we're going to use the formula circumference equals 2 pi r. So if the circumference is 18.8, that's going to be equal to 2 pi r. And then what I would do is I would do this on my calculator in 2 steps. The first thing I would do is divide both sides by 2. When I do that, 18.8 divided by 2 is 9.4. So I get 9.4 equals pi times r. And then divide both sides by pi to cancel out those. And I do 9.4 divided by pi. After you round, you'll get 3.0 yards. Again, make sure that you're checking that on your own. Or Another way in which you might approach it is just using the formula circumference equals pi times diameter. Because what you could do is figure out what the diameter is, and then if I want the radius, I could just cut it in half. So you could do 18.8 is equal to pi times d. You could divide both sides by pi, and then if I do 18.8 divided by pi, we'll get that the diameter is 5.984 and a few more decimal places. I'm going to take that answer, just divide it by 2 to get 2.992 with a few more decimal places. And that, if I divide that by 2, my radius is going to be half that diameter. Multiplying by 1/2 by 0.5 or dividing by 2 is the same thing. And that will get you the same answer that we got above, 3.0. Hold on. This is the radius here. That's when I divided by 2. So we'll just say down here that radius is 3.0 yards. So we got the same answer doing either way. Okay. Now, for the next set of problems, we have to find the area of each circle using our calculator's value of pi. So, for number 9, the formula for the area of a circle is pi r squared. R is the radius, and in this problem, that radius is 8.8. So, 8.8 squared. Now, some calculators, you could type that all in one step. Maybe you'd want to do the order of operations, do the 8.8 squared first. If I do it that way, 8.8 squared is 77.44. And I'm going to be multiplying that by pi. And when I do that, rounding to the nearest tenth, you should get 243.3 square yards, or yards squared. So if you're given the radius, substitute that radius right into our formula, and that'll give you the area. For number 11, this time they gave us the diameter. So what I'm going to do is use that to figure out the radius, since that's what the area formula it uses. So the radius is 1/2 the diameter. So that's going to be 1/2 times 15.2, which is 7.6. Now I can use that in my area formula. A equals pi r squared. So that's going to be pi times 7.6 squared. You could do 7.6 times 7.6, get that answer, multiply that by pi, and you should get 181.5 square inches. And then finally, last one, number 13, I want to find the circumference of the circle. Well, let me backtrack. You're given the circumference, and now we have to use that to find the area. Well, to get the area, I need the radius. So, since I'm given the circumference, I'm going to approach it kind of like what we did for number 7. Because for number 7, we were given the circumference, and we use that to get the area. Then, once we know the radius, no, let me say that one more time. We were given the circumference, and we had to find the radius. Now, once we know the radius, we can use that to find the area. So the method I'm going to do is I'm going to use this method to figure out the radius. So I'm going to find the diameter first. Circumference equals pi times diameter. So 69.1 is my circumference. That equals pi times diameter. Divide both sides by pi so that the pi's cancel out. If I type that into my calculator, I get my diameter D is equal to 21.995 with a whole bunch of decimal places. The radius is going to be half that diameter. So half of 21.995. So I could either multiply it by 0.5 or divide that by 2. And when you do that, you get 10.998, which is approximately 11 feet. Well, that's not our final answer because we want to find the area. We want to find the area. If we know the circumference, we just got the radius. Now let's use that radius to get the area. Let's move this over a little bit, get it out of the way there. So we're going to do area equals pi times 11 squared. And if I type that into my calculator, and make sure you go back and try that on your own, you'll get 380.1 square feet for the area of the circle. If there's anything that you are stuck on here, if there's any questions that you have, please don't hesitate to raise your hand and ask us any questions. So we learned how to solve problems involving the circumference of a circle and how to solve problems involving the area of the circle. Again, let me know if you have any questions.